Much better. Okay, so if that's a square, that is its vanishing point, right? This is the eye level. Now, where is my viewer? Oh, it's like, okay, I'm going to show you one of the weirdest things about perspective. When you're doing something in perspective, it's actually kind of a trick of geometry. In that, in the one sense, it's as if we're looking out this window. All right? But my viewer, me, I'm on this side of the window. So how do I draw my viewer into there? It's a weird idea. What you're trying to do is you're kind of imagining when you draw a perspective space and you use the geometry. Imagine this. Imagine, have you guys seen those trick cameras that show, like on a single image, they'll show like a 180-degree view, and in the extremes you see these incredible warping taking place? That's the geometry we're working with. Now, that's how we can draw the viewer. I can put my feet in the picture that way by doing this. Let me show you. Let's operate with the idea that this is a square. If it is a square, and I draw corner to corner like that, okay, what do I know? I know that these angles both have to be 45 degrees. Because it's a square. Alright? Now, if there are basically two laws about perspective. There are two things you have that basically, these two laws about perspective determine everything else. And if you were sufficiently brilliant, you could deduce everything in this entire semester from these two laws. And the first one is this. Things get smaller. The second law is if lines are parallel, they will, if foreshortened, they will appear to converge to a point. Okay, everything else goes back to those two things. So, you guys, this vanishing point here, okay, is for any line that's going at that angle. So if I wanted to draw another line here, and I made it parallel to the side, it would look like this. You see what I mean? Because it's at the same angle. Now what if I did this? See what I mean? So this, I'm going to call a diagonal vanishing point. And I'm going to put 45-degree angle there because it's basically four lines that are 45 degrees off of the picture plane. Am I making sense here so far? All right, now, so if this is a 45 here, that's a 45-degree angle in space. If I do some, you know what, I'm going to get my little ruler here. Some lines I want to draw straight. I want you guys to look at this for a second. If you take a look at what angle these lines actually are, let me get out a protractor here just so I can prove it to you. This is a 45-degree line, but actually right here where it crosses that line, it's actually a 14 Or no, yeah, it's about 14 degrees. So this is actually about 14 degrees, in terms of visual reality, if we flatten it. But we know it's a 45. But now look what happens. As I draw down this line, I get steeper angles. So for instance, here, this line, hey, we're up to 24 degrees, or 27 degrees. And look, we're at 40 degrees. See what's happening? We're getting closer to the real number. And there comes a point where it's actually a 45-degree angle. Now let me ask you something. Where is the only place that can be true? The only, yeah. It's where the viewer's standing. So basically, it's like I'm going like this. Watch. It's like I'm going like this. If you guys look down at the floor for a second. The squares are 90 degrees. They're actual 90s. But if you look out, they're not. Make sense?
Yeah.
Seem pretty obvious? Okay. Now, so we're going to call this the station point. The geometry allows us to draw this into our drawing, or to draw this onto the page. We wouldn't normally have it in our drawing. We would crop the image, so like say our image would be cropped like this. But that's how we can find where the station point is. Now, at the station point, any angle that you draw is going to be true. It's going to be actually what it is. So a 30-degree angle at the station point is going to be 30 degrees. A 60-degree angle is going to be 60 degrees. A 90 is going to be 90. Now, this has some really important things, as you're going to see in the next 40 minutes or so. Okay, but did I lose anybody? Because this is like the most basic thing. And this allows you to prove that, okay, actually this is what this allows you to prove, just to state it absolutely. That is a square if my viewer's right there. If my viewer is anywhere else, that is a rectangle. It is not a square. Because anywhere else would change this angle and would make it a 40 or a 80 or some other degree. And if it's some other degree, then we know it's a rectangle and not a true square. Does that make sense? Okay. There's fun stuff coming. Let's see. Is this our 4th class? Yes. All right, Brandon, I'm going to try something here. You ready for it? Oh.